Arshan, good evening. I hope you can hear me. So, actually, we discussed that you take an alkyl halide alkoxide, and it is a substitution SN2 reaction on an alkyl halide. Okay, so you need to be careful regarding the choice of alkoxide and alkyl halide. More specifically, you need to think of the alkyl halide. Your alkyl group should not be tertiary. Okay, because tertiary alkyl halide will not undergo SN2 reaction. Is it clear?
Yes, sir, clear.
Right. So how you are going to prepare anisole? Anisole is an aromatic ether. This is a common name. So what's the structure of anisole? Who is going to tell me? Arshan? Anisole, aromatic. It is actually an aromatic ether. Yeah, tell me. Who's going to tell me quickly? Anisole. It is methoxybenzene. Clear?
Yes, sir.
Okay, so methoxybenzene. And how you are going to prepare it? Imad, Arshan, Anushka, Ryan. Actually, by Williamson ether synthesis, how you are going to prepare it? You need to take, I can give you the two choice which we are having in front of us. And those are, either you can break it in this way. Okay. And as per this choice, you need to take oxygen with phenol. That means phenoxide ion. Okay. And CH3. I. Okay. Or Br, whatever. Alkyl halide. As per this choice. Oh, there is one more choice. You can select this one. You can take chlorobenzene or bromobenzene or iodobenzene, any alkyl halide. Alkyl halide you have taken instead of alkyl halide, you have taken aromatic. And oxygen you took with methyl. I'm talking about this one. Yeah. So now tell me which is going to be the most suitable choice. So in this case, we can theoretically we can make the anisole. O minus will come and attack on the CH3 and I minus is going to come out, right? And we are going to have pH OCH3 and NAI. And this also theoretically I can show you. And the OCH3 is going to come in and push out the Cl. I hope everybody is getting me what I'm trying to say. So which method you are going to adopt? Tell me quickly. Anushka, Shen, Imad, Riyan.
Sir, the left-hand side one.
Yeah. Which one? The left.
Sir, the second.
This is let name them. This is the first method. And this is the second method. Okay.
Sir, the first one.
First one is better or the second one?
I think the second one.
Second one, theoretically. And Arshin and Ryan, would you like to add something? Yeah, tell me. The first is the more appropriate. Okay. But why? You need to tell me. Why you need to think that why first is more appropriate one? Any
Sir,
idea?
the bond is easier to break between.
Pardon?
So is it because the bond is easier to break in the
Yeah,
first
bond
one?
is easier to break. Yeah. So which bond will be difficult to break in the second one? Yeah, you have directly come to the point. Right. So which bond is going to be difficult? If you take second, means in second, it is difficult for us to break. Okay. Yeah. So Imad, Ryan, and Arshan, the bond which is difficult to break will be the carbon chlorine bond. The lone pair of the chlorine will try to overlap with the benzene ring electrons, double electrons of the double bond. And by this carbon chlorine bond acquire partial double bond character. Remember we studied Dawes process. Okay. And Dawes process actually, in that we have seen that it was very difficult. Okay, we took very high temperature and pressure. So this substitution is not going to occur normally. It is going to be very difficult because Imad, what I should write here?
Aqueous particles. Yeah.
Carbon chlorine bond acquire partial double bond character due to resonance. Okay.
Okay.
So that's why it becomes very difficult to break. So you will choose this method. Okay. So there was one more method which we discussed. And that method was we discussed acid catalyzed dehydration of alcohols. Okay. And we discussed ethanol. So when we took the temperature 170 degrees Celsius, with conc H2SO for heat, so actually water get eliminated. Or you can take H3PO4 also. So I'm going to write minus H2O. And I'm going to end up with an alkene. This is acid catalyzed dehydration elimination reaction, and we have seen the more substituted, more branched alkene is going to be the major product. Right? That's what we discussed. And this is elimination reaction. Elimination, actually you are forming a weaker bond, pi bond, you need more heat. You need to give in energy. Okay. Clear? So if you take less temperature, then the double bond is not going to form. And how much was the temperature? Can any one of you tell me? Yeah, to get the ether. Any idea? Remember acid catalyzed dehydration of alcohols? We discussed it in the reaction. Okay, we discussed it while doing the reactions. Okay, so what we did was we heated alcohol ethanol with at 170. That each alcohol will have different temperature. Okay, for ethanol it was 170 degree, and heating ethanol at 170 degree will give you ethene due to the removal of water in the presence of conc H2SO4. But if you would have taken low temperature, low, how much low? That was 140 degrees Celsius. Okay. What you will do, you will take two ethanol molecule, you will remove H and OH from two molecules, and that is going to give you Harshan and ether. Clear?
Yes, sir.
How ether is going to form? So 140 degrees Celsius. By heating 140 degrees Celsius, double bond will not form. You will end up with an ether. How this has happened? First of all, H plus will protonate. Protonate means it will give H2SO4 will protonate the OH group. OH group has become OH2 plus. Okay, and it is ready to leave. It is ready to leave as water. Okay, but now we have two options. Okay, and the two options are the OH comes out as water, leaving behind a carbocation, and the H plus is also removed by heating with a concentrated H2SO4. But that occurs at high temperature. Okay, but if you would have taken less temperature, 140 degrees Celsius, then this ethanol molecule is going to attack on the other molecule, and you are going to have this. The water will get removed, but you will have two molecules joined by oxygen atom. So you are going to get a diethyl ether, right? I hope it is clear to all of you.
Yes,
Any
sir.
doubts in this?
Yes, sir.
Arshad, Imad, very important. Okay. So you can prepare by Williamson ether synthesis, or you can directly take alcohol, heat them in the presence of acid, but you need to be very careful with respect to the temperature. Okay. So now the next thing is, this is making of ethers. Next is breaking of ethers. How do you break ethers? Any idea? Actually, breaking of ether is just a common way of writing. Actually, the more appropriate way would have been cleavage of ethers. Okay. Ethers can break in acidic medium, just like the alcohols. You can see the alcohols also reacted in acidic medium. Why alcohol require acidic medium to react? It is because of the acidic medium. It is their OH group is gets protonated and it becomes a good leaving group. Okay, it comes out as water. Okay. So you require acidic medium, and so the most famous way of breaking the ethers into two fragments is using HR. Why we use HR? Any idea? Anushka, Ima, Darshan, Rayan,
No.
why do we use HI?
HI or HR?
HI. This one. This is the most famous. We can use dilute H2SO4 also. This is the most famous reaction. But why do we use it? Why not other acid? Other acids can also be used, but this is the most famous. It is because HI is a very strong acid.
So is it because it protonates?
Yeah,
ether
that is the
oxygen?
actual reason. Yeah. So you require acidic medium first of all, because basic medium is not going to do anything to ethers. So you took some acid, HI, and H plus is going to come out, and that is going to get connected to oxygen, lone pair of the oxygen. CH3, CH2, O. Okay. So I will write the product first and then I will show you the mechanism, which is very easy. Okay. So this is the overall product. But even if you don't know the mechanism, it is very easy to write the product. Okay. So what's the easiest way to write the product? That's very simple. And if it is a symmetrical ether, then it is very easy. And this is the mechanism which you can use for hydrolysis and many other chapters also. Okay. Cleave the carbon oxygen bond, put hydrogen on the oxygen, and if it is water, put OH on the other side. But in this case, it is not water, it is HI, so put I on the other side. Right? CH3, CH2OH. Yeah, it's very simple. This is without knowing the mechanism. Just if you want to do it quickly, if you want to get the answer as quickly as possible without getting into the details. Okay. So with HI 1 mole. And what's going to be the answer, Arshin, if you would have taken 2 moles of HI? Yeah. Tell me. Yeah. What's going to be the product? If you break with 1 mole of HI, the one product is alcohol, another is alkali. Yeah. Yeah, who's going to tell me the answer quickly? Yeah.
Sir, I'm not sure.
Yeah, you can try. No problem. It's very simple. If you have this is the shortcut. If you would have taken 2 mole of HI, write 1 more HI. H on oxygen and I on other side. Okay.
Sir,
Yeah.
sir, could you explain this again?
Yeah, I will explain. No problem. With 1 mole, is it clear? This is just a shortcut. I'm going to explain with more examples. So 1 mole, choose any carbon oxygen bond, break it, put hydrogen on the oxygen and iodine on the carbon. That's how I get this answer. Right?
Yes, sir.
If you would have taken 2 moles of HI, that means the reaction is going to happen one more time. 2 times the reaction is going to happen. One time you have already completed the reaction. While doing the reaction second time, there are 2 molecules. One is alcohol, another is alkyl iodide. The alcohol can react. Okay, alcohol can react with HI. Remember, we prepared alkyl halides.
Yes, sir.
From alcohols by reacting with HX. So HI, so this OH is going to get protonated with this H plus. It is going to come out as water. And who's going to come and join in the place of OH? Iodide. Clear? So you will have 2 moles of iodide. Right? This is a normal shortcut, but you need to be very careful. If you have different questions, this is the most simplest question. Okay. Harshin, is it clear? Imad?
Yes, sir.
Okay. So let's do one more question. And suppose if I took 1 mole of HI and if I have taken 2 moles of HI. Yeah, what's going to be the answer? So with 1 mole, just break carbon oxygen bond, put hydrogen on the HI. This is HI, okay? Put hydrogen on the oxygen and iodine on the CH3. Arshin, is it clear? Anushka?
Yes. Sir, how do we decide where does the hydrogen go and where does the iodine go?
Actually, oxygen is negative, okay? Because it is electronegative atom, right?
Yes, sir.
And carbon is positive. On the basis of electronegativity difference. Is it
Yes,
clear?
sir.
On the basis of electronegativity difference, so H is plus, so I will connect plus to minus, and I is minus, so I connected it with carbon plus. Clear?
Yes, sir.
That's how I decided where to put H and where to put I. Right?
Yes, sir.
Okay. So again, if 2 moles are given, so this is how I will get the answer. If 2 moles are given, I will react this alcohol with 1 mole of HI again. Okay, twice I will do the reaction. Like this. Okay. H on oxygen and I on CH3. 2CH3I plus water. I hope it is clear. Okay.
Yes, sir.
Arshan, Imad, Ryan, clear?
Yes, sir, clear.
So this is the simplest case when the two alkyl groups are same. If the two alkyl groups are same, then it is not a matter of concern. Okay, but the concern arises when you have two different alkyl groups. Okay, then it is a problem. Okay, suppose if I take this ether, then it is a problem for me. Even with the shortcut, I'm not sure whether I'm going to get the answer or not. So I can put hydrogen.
Sir, here as well, H will go get attached to O and I to CH3.
Yeah, I, H on O and I, where I should put I?
Sir, CH3.
This is option 1. Yeah, correct. But why not this one? This is option 2. With option 1, I'm going to get, this is option 1, this cleavage. Okay. Just to bring your attention, I have put 1 and 2 types of lines. Option 2 is this one. So I will put hydrogen and oxygen, but I will put iodine on the benzene ring. And so OH is going to go with in option 2 with CH3. Right?
Sir, it cannot be option 2 because the benzene ring, I guess, has got carbon bonds and iodine cannot be attached to that, to the benzene ring. That's
Yeah. Exactly. This bond, remember, this is a special case. Just like in the above, in while breaking, benzene and oxygen, benzene chlorine bond are a bit difficult. Is it clear?
Yes, sir.
It is difficult. Why? Because of the resonance. So option 2 is incorrect. Option 1 is correct. You can write benzene and oxygen bond. The reason you can write Imad and Rehan, you can see over here. There is a partial double bond character due to resonance. This lone pair forms a bond with the benzene. Benzene is phenyl PHO bond. Arshan, is it clear?
Yes, sir.
Okay, so this bond is not. So even if you would have taken 2 moles of HR, the answer is going to be same. So this is not going to be the answer, because I have, in order to create this, I have cleaved the benzene oxygen bond, which is not going to get cleaved. Okay, that is difficult. And so even with that, in this case, it is different. Remember, guys, I told you this was the simplest case. Okay, so in this, if you would have taken 2 mole of HI, then also your answer is going to remain same, because again the PHOH is not going to react with the HI. So, but in the above case, when you took 2 moles of HI, both the alkyl groups got attached to I, and the oxygen was attached to hydrogen on both the sides, so you ended up with water. Clear?
Yes, sir, clear.
So this is one type of problem while you break the ethers with HI. There is one more type of problem. And there is one more type of problem related to the cleavage of ether. And this is bit more difficult. Difficult with respect to both cases which we discussed above. This is which ether, what is the IUPAC name of this ether? Yeah, tell me. What is the IUPAC name of the ether? Select the parent chain. Parent chain is propyl. And ethers are always written as substituents, means they always occupy ethers, halides, and NO2. They always occupy prefixes. Okay, so the main chain is propane, imad, clear, and on the propane, on second carbon you have methoxy and methyl. So 2-methoxy. I'm going to write them in the alphabetical order. And 2-methyl. Actually, meth is same, O is coming before Y, so I chose to write methoxy first, then methyl. Okay, 2-methoxy, 2-methyl propane. Is it clear? This is the IUPAC name. I hope everybody is getting. Harshan, Rayan, Anushka, Emma, right? And the common name is this is methyl and this is tertiary methyl. Tertiary butyl because it is carbon alkyl group having 4 carbon atom butyl, and it is tertiary carbon. This is the common name, methyl tertiary butyl ether. Okay. Now the next thing is, so you made this ether in Williamson ether synthesis, where you took the methoxide or the tertiary butoxide as the alkoxide ion and methyl iodide as the alkyl halide. Why you chose Methyl halide, because methyl halide being small can easily be attacked by tertiary butoxide. Okay. But while breaking, you need to be very careful, especially with 1 mole. With 2 mole, it is not a problem. With 1 mole, you need to be very careful at how you are going to break it. So HI. So what am I going to get? So you here also you were having two options. So for the unsymmetrical ether, you need to think. For symmetrical ethers, it is not a matter of concern. Just break the CO bond, put OH and I. Okay. Clear? But it is a matter, it is going to be a matter of concern. The way in which you break the carbon oxygen bond, you need to select it by thinking. Okay. So HI, what going to be the two options? CH3I and OH. Methyl halide and tertiary butanol. The other option is going to be methanol. So which option you are going to choose? Tell me quickly. And this is a very famous question. CH3OH and tertiary butyl halide. Yeah, this is correct. This is incorrect. Why? Anushka, Arshin, any idea?
Sir, again, it's because of the resonance.
No, but resonance can't happen over here because there are no double bonds. Oxygen can't do resonance. On both sides, it is having a simple carbon sp3 carbon which is connected to 4 single bond. Resonance happen wherever you have doubly bonded group, which in fact is not there on neither of the sides. Okay. So this is going to be the answer. Let me just make you recall the thing which we discussed just 2-3 classes back. If you are breaking the OH bond, okay, in alcohol or ether, in alcohol we discussed. So primary is going to be faster than secondary and tertiary is going to be the slowest. But if you are comparing the rates of the breaking of the carbon oxygen bond, then tertiary, secondary, and primary. That's going to be the way in which the alcohol will get. So this was also the rate of dehydration. Actually, the cation formed is very stable. That is the reason. Okay. In this case, so this is tertiary and this is not. This is tertiary, and this is not even primary. This is 0 degree. Okay, methyl. So break this bond. Tertiary alkyl group can easily separate from electronegative atom because the cation formed is stable. That's the overall picture of explanation. Okay, actually, let me tell you why it is happening in detail. The mechanism is required because first of all, it is given in NCRT also, and you need to, in order to write the product, you need to know the mechanism. Arshin, are you getting it?
once again, please?
Pardon?
Can you just explain it once again, sir?
Yeah, I'm explaining, right? So if the carbon oxygen bond is going to break more easily, if you are comparing the breaking of carbon oxygen bond, always remember it is going to be, its breaking is more easily if you have a tertiary alcohol then, or tertiary group carbon, or secondary and primary. The ease of breaking of the carbon oxygen bond is going to be maximum for tertiary, followed by secondary, and then for primary. Okay, clear?
Yes, sir. Understood.
So this what I chose to break, because it was tertiary, so it was easy to cleave. Okay, because the reason is actually that the carbocation can form more easily. That is the reason. And let me show you the mechanism. First of all, H plus will be given from the HI. The H plus is going to come and join the lone pair of oxygen. OH. Okay. But this is the first step. Till now, we have not broken anything. So, why ether can break easily in acidic medium? It is because in acidic medium, the H plus comes in and join at the lone pair of the oxygen, means the ether get protonated. And now tell me how it is going to break. Okay. So carbon oxygen bond are same on both the side. They both are carbon oxygen only. But the thing is, once this oxygen separate by pulling the electron, bonded electron pair on itself, it will leave behind a carbocation. Getting it? It is going to leave behind a positively charged carbon atom. Is it clear or not? And because tertiary carbocation is stable, so it is the choice. This is not going to be the choice for breaking the carbon oxide, right? Why I've chosen this? Because tertiary carbocations are more branched and they are more stable. Okay. So finally, not only H plus came in, I minus also came in. So I plus will have no option other than attaching itself to the tertiary alkyl group. Clear?
Yes, sir.
Yes, okay.
Okay. So this is SN1 mechanism. In SN1, actually, what happens in alkyl halide also we have seen. In tertiary, SN1 happens where the leaving group come out on its own, leaving behind a carbocation. And then that carbon carbocation will be attacked by the group which brings in the lone pair, the iodide group. Okay. This is how you are going to get the answer. Right? Clear or not? Tell me quickly.
Yeah.
Okay. The other thing is, but it is not going to be SN1 all the time. Arshin, is it clear?
Yes, sir.
Okay, this is bit tricky and and it is given in the NCRT also, so you need to be very careful. Okay, and there is one more type. Actually, just remember that whenever you have unsymmetrical ethers, then only you have to be careful. If the ether is symmetrical, then our life is very easy. You can get the answer very easily. It is not the matter of concern. Where should I put I? Where should I put H? Okay, make OH and I. I you can connect it to any alkyl group. Then it is not the problem. But the problem arises only when you have two different alkyl groups. So then we need to think, where should I connect I? Okay. So that is the problem. So now the next question, last question related to this, and that is this is which ether? Tell me. Which ether is this? What is the name? Himad? Rian? Anushka, tell me, what is the name of this ether?
Something methyl, sir.
Methoxy. The smaller alkyl group you are going to take with the oxygen. Methoxy. Ethane. Methoxy ethane. The IUPAC name is going to be ethyl methyl ether. The common name. This is the IUPAC. Ethyl is written first because E comes before M. In alphabetical sequence, I have written ethyl methyl ether. Okay. And now HI. What's going to be the answer? Yeah, tell me quickly.
Sir, second one.
The right one or the left one?
Sir, the right one.
Right one is going to be the right answer. Correct. Why? What's the reason? Arshin, Imad, Ryan. What's your choice of answer?
Sir, mine was actually the left side.
Left one. Okay.
Yeah.
Actually, you may have thought in this manner the above question. Okay. Let me cover this and then I will tell you the main thing. Arshan,
Yes, sir.
what's your choice of answer? The right one or the left one? Left one? Okay, but right one is the answer. So first of all, so in this case you need to know the mechanism, then only you can answer it. CH3, and this is given in NCERT also. So CH3, CH2O, CH3, first of all I'm going to put H without thinking anything else. First I will protonate the oxygen, and in this there is no problem. I don't have to break the carbon bond. Okay. Now the next thing is, in which way should I break the carbon oxygen bond? So my question is the mechanism SN1 or SN2? Is the mechanism SN1 or SN? Pardon?
Or SN1.
SN1.
SN1 can happen only if you have a branched carbocation. Highly branched. SN1, that's my question. And this is not my question. If you have any question in the examination, you are going to ask yourself this question only. Then only you will be able to solve it. Okay. SN1 or SN2? Okay. So SN1 occurs SN1 occurs if we have a stable carbocation. And the carbocations are stable only if you have a tertiary alkyl group, or if you have benzylic carbocation. Okay. These carbocations are very stable. Okay. And primary and secondary carbocations, methyl primary and secondary carbocations, primary and secondary carbocation can't form because they are not very stable. Okay. So if there is any tertiary group or benzylic group, this is benzylic. Then it can form easily. If there is a tertiary, carbocation can form. If it is allylic, then carbocation can form. Okay. But methyl primary, secondary carbocation will not form. So now my question is, will the carbocation form in this or not? Tell me. Is the carbocation going to form in this case or not? Yeah. What's the answer? We need to look at the structure of the alkyl groups. Is the carbocation going to form or not? So this is methyl. And this is ethyl. Okay. None of them is tertiary or benzylic. None of them are capable of forming carbocation. Is it clear?
Yes,
Arshan,
sir.
okay. So if you have a tertiary group, then only the carbocation can form. But if you have primary and secondary group, the carbocation cannot form. Because the primary and secondary carbocations are not stable. So this will help me to decide the mechanism. It can't be SN1 because carbocation cannot form. Clear? So the mechanism is not SN. I will rule out the possibility of SN1 mechanism. I will rule out the possibility of SN1. Only now the choice is SN2. Substitution nucleophilic bimolecular. So how the SN2 was happening? Remember? How it was happening? One group was coming in, the nucleophile was coming in and joining with the carbon atom, and the leaving group is simultaneously coming out. It is breaking away from the structure of the substrate. Simultaneous SN2 means bimolecular, and the main thing which I would like to say is simultaneous bond breaking and forming. Simultaneous bond forming with the nucleophile and bond, just a second, bond breaking with the leaving group. So let me come over here, this one. The nucleophile was I minus, okay, and so the nucleophile, the bond carbocation will not form on its own. The nucleophile is going to come and push away the leaving group. But now where the nucleophile is going to come and push, where it can form, where it can join itself more easily, it is the place where which is a smaller group. Smaller group is less crowded. Okay, less crowded means the nucleophile can come in and join itself more easily. So in SN2 will happen if you have primary and secondary alkyl groups. Okay, and the nucleophile is going to the nucleophile is none other than I minus. Okay, so the nucleophile is going to come and join itself to the smaller alkyl group, because that's where the SN2 can happen more easily. And if any of the alkyl group is branched like this one, then SN1 is going to happen, that branch alkyl group branch. Let me be more precise, that branch is tertiary. If there is a tertiary alkyl group, that is going to come out as carbocation, and that's where the iodide is going to join itself. Clear? So SN2, you can write in SN2 I minus will attach itself to smaller alkyl, because that's where the I minus can join itself easily. So this is going to be CH3I. So this is a tricky thing actually, and a difficult thing. for most of the students. And this is going to be the answer. Clear or not? You need to decide whether the mechanism is SN2 or SN1. And based on that, you need to come to any conclusion. So this is the most difficult part, but it is there in the NCERT also. Okay. Very, very important. Any doubts in this? Tell me. So let me take some example of NCERT. But these are very good questions. Yeah, Anushka, tell me the answer.
Sir, in the first one, I will be attached to CH2 and O
Yeah,
and H2.
H will be attached to O. Yeah, CH2I. Correct. I and H. Arshin, why we are breaking it in this way? Actually, this bond is not going to break. That's what the reason is. Imad, is it clear?
Yes or no?
It is not going to break because the oxygen is directly connected to benzene. It will delocalize its electron with the benzene. So it will have double bond. So it is very difficult to break the double bond. And so that I'm breaking this from this side, putting H on oxygen, and the CH2 that will break, and I will put I on the CH2. So that's how I'm going to get the answer. Clear? And so the answer is going to be, but in this case, you are not going to discuss SN1 or SN2. Just think that you are not going to break the oxygen directly connected to, not going to break the bond which is directly linked to the benzene. Okay. CH2. And what's going to be the answer for the second one? Tell me quickly.
Sir, in
Arshan,
this, will the I be attached to the CH2 that is directly attached to O? Will it be like
pardon?
that? Sir, will the I be attached to CH2 and H2O?
Yeah. No, you are giving the answer for the second one.
Yes, sir.
Okay, the I will be attached to
CH2.
CH2 or C. So first of all, think that whether there is any group which can form a cation. Arshan, any group which can form a cation easily? Pardon? Yeah, tertiary. Exactly. So this is the place where you can have tertiary cations are very stable. So this is the place where you can have the plus charge. Plus charge can reside easily on this. So if the plus charge come, I'm going to put the I minus on this carbon. Anushka, is it clear?
Yes, sir, clear.
Imad,
Yes, ma'am.
okay, it is SN1. Let me take the another example. There are 3 questions and all 3 are very nice. So 2 are already I have taken. The other one is the third one. It is example 11.7. Okay, from the textbook itself, but very good example. So that's why we are covering it. So in this one, so just think that is there any alkyl group, either this one or this one, which can form a stable carbocation?
Sir, that one, left-hand side.
Which one?
The left-hand side.
It appears to form a stable carbocation. Yeah, it appears, but actually it is not.
Sir, I didn't understand.
Yeah,
I didn't understand why it
yeah,
will not
because yeah, it appears to be tertiary, but actually you need to look at this carbon. This is primary. It is connected only to one carbon. And this is also primary. Clear? 1 degree. It appears to be branched, but in this case it was tertiary. Look here. So carbocation was very stable. Okay. But in this case, the carbocation is not stable because though it is branched, it has tertiary carbon, but the tertiary carbon is actually bit ahead. It is not directly linked to oxygen. It is the primary carbon. Clear?
Yes, sir.
So the primary carbon, both are primary. So now Arshin, tell me where the I minus is going to come and join itself. Which one? On the right group or the on the left? Left is actually, yeah, that is also primary, and
Both are primary.
yeah, both are primary, but where the I minus can approach more easily.
Maybe right
Sir,
side
would
because
it be the right
oxygen is near.
Yeah, right hand side, because that is more smaller group. So I minus can come in and it will can come in and approach the carbon more easily, because here the carbocation is not forming, and if the carbocation is not forming, then we need to decide where should the nucleophile proceed. So if the nucleophile is given choice to go and attach itself to a alkyl group which is not yet completely formed a cation, then the nucleophile will preferably go to the alkyl group which is going to be smaller. Okay. because the bigger group is going to pose, because it is more branch, so the bigger group is going to pose more repulsion. A smaller group is going to pose less repulsion. Is it clear or not?
Yes, sir. Clear.
Okay, so that's what we discussed in this question also. This is also very famous, very basic question. So we join I minus to methyl. Okay, the smaller alkyl group. So if the carbocation is forming, join the mechanism is going to be SN1 and join the alkyl group on the more branched side. But if the both the carbon are primary or secondary, and the carbocation cannot form a stable carbocation cannot form, the mechanism will be SN2. Under that circumstances, the I minus will join itself to the carbon atom which is smaller, which is less bulky, which is less crowded. So this one. Clear or not?
Yes, sir. Clear.
But this is a very important question. And everybody make mistake in this. Okay, so don't worry. It is not difficult for you, it's difficult for everyone. Okay?
Sir,
Yeah.
sir, questions like these come for how many marks?
Yeah, they can come for just actually in a group, they can come. Okay, for 2-3 marks. It depends what they are trying to ask for. It is it a part of the complete group of questions or just a single question,
Yes, sir.
right?
Then do we have to also reason why the answer is like that, or should we just
Yeah,
write
you
it
can
silent?
you can just mention SN2 because none of the alkyl group can form a stable carbocation. It is SN2, and if it is SN2, the nucleophile is going to attach itself to the smaller alkyl group, which is less bulky, which is easier to approach.
Yes, sir.
But if there is a more substituted alkyl group, more branched alkyl group, then you are going to break that alkyl group ahead of the attack of I minus. And
Yes,
that's
sir.
going to, because it is going to form a stable cation, and if it forms a cation ahead prior to the attack of I minus, then it is SN1. Okay, clear?
Yes, sir.
Yeah.
Yes, sir. Clear.
Right. The reactions of anisole are going to be electrophilic aromatic substitution. They are going to be same. These are the reactions of ethers. Let me tell you one more thing. Ethers are actually highly explosive. Okay, during the transfer or what happens, they react with oxygen and they actually explode, form explosive hydroperoxides. That also you can make out. Ethers are soluble in concentrated H2S4 because of the formation of this oxonium ion, which is the protonated form of ether. Okay. Reactions of anisole are electrophilic aromatic substitution, which are exactly similar to the reaction of phenol of anisole. So anisole actually it is orthopara directing group. So cleavage already we discussed with HI. We also prepared anisole, okay, by taking phenoxidine and CH3I. Now these are some other reactions which are not related to the ether. These are related to the benzene ring. So first of all, let me tell you, these lone pair of oxygen are getting involved in delocalization. So this anisole is having minus charge at ortho, para, and ortho position. It is more rich. Okay. So if you have an electrophile, some positively charged species which is in seeking electrons. So ortho and para positions are the most appropriate positions. Okay. So this is ortho-para directing. Harshin, why it is ortho-para? Tell me. Yeah, Harshin. Why it is ortho-para directing?
I don't know, sir.
Actually, the lone pair of oxygen, okay, it actually get involved in bonding. You can write the resonance structures. Not every time you have to write, but you need to have in your mind, and you will get the all the answers for all in all the chapters for aromatic compounds. This oxygen is will form a bond, try to form a bond, but this carbon already making 4 bonds. You can look over here. So if the oxygen is trying to make one more bond, carbon cannot have 5 bond. I need to shift one bond and put away its electron pair on the adjacent carbon atom. Is it clear? So oxygen now will have plus charge. There will be only one electron pair left. Lone pair. The lone pair. This is a pair of electron which was actually present in the double bond, and now it is pushed aside on the ortho position. This lone pair is not going to sit over here only. It can move ahead because here also the story is same. This carbon hydrogen is already there, though we don't write it. This oxygen, this negative is going to form a bond, and it is going to push the pi electron density. So the negative charge is going to come at the para position. So you can just draw this structure. Need to have little bit in your mind. No need to write the actual structures, but this is going to guide you throughout your reactions. Because as you can see over here, the ortho-para positions are electron rich. They have more electron density. The electrophile is going to come and join in at the ortho and para positions more easily, because electrophile is electron loving species, and wherever the electron density is more, those are the positions where the electrophile is going to join its. I hope this is clear to all of you. Arshin, getting it?
Yes, sir.
Imad, Anushka, Rayan,
Sir, understood.
right? So this electrophile can be of different types. Okay, it depends upon the type of reaction, actual electrophile which you have taken, but the overall outcome is going to be same. It is orthopara. Activating means it can react more quickly. So let's take the specific example. So this Cl will be removed by the AlCl3. You will have CH3 plus, that will be the electrophile. And that is going to come either at the ortho position or at the para position. So this is Friedel-Crafts alkylation, where you bring in the electrophile as alkyl cation. Okay. So here also the Cl will get removed, Cu plus. The electrophile is going to be CH3 Cu plus. And that is going to come at the ortho and para questions. You can do the nitration also. In nitration, you take the mixed acid and the actual attacking species. The H2SO4 removes the water and leave behind the NO2 plus, which is the electrophile. Okay. Clear? So these are actually some of the reactions of your anisole. Okay, they are same exact that of phenol, but actually in the case of phenol, the reactivity was very high. Okay, because phenol was turned itself to phenoxide ion in water. That's what we have seen, and that O minus was doing the resonance. Okay. Okay. So now some physical properties. Physical properties, ether are very volatile. Yeah. So among alkane, alcohol, ether, what's going to be the boiling point order? Yeah, Imad. Any idea?
Can you repeat the question?
It is going to be maximum for whom?
One.
For comparable, for same molecular weight. It is going to be maximum for alcohol.
Why not alkene?
Alkane actually are non-polar.
Okay.
So smaller alkanes are gases. Right? Normally smaller alkanes are gases. Okay. Lowest boiling point, right? But larger alkanes, suppose if you have large alkane, if it is having more number of carbon atoms, then it could be more. But if the number of carbon atoms are same, then you have alkanes will have low boiling point and alcohols will have highest. Ethers will be somewhere in the middle, right?
Yes.
Okay. So I hope this is clear. Okay. So alcohol, why the alcohol is boiling point are higher? What's the reason, Arshan? So it is due to hydrogen bonding. Because OH is there, no, in alcohol. So not with the R.